A function defined on 0, 2, such that the derivative exists, but it's not continuous at a particular point. We fussed around with functions like x squared sine 1 over x, right? And what did we find? If x is not 0, 0, if x is 0. And what did we find? We found maybe it was x cubed. I think we found this one to be differentiable, but the derivative wasn't continuous at 0.
Yeah. No, you're talking about the one you did in class the other day?
Yeah.
You did x cubed sine pi over x.
Oh, okay. Okay.
Just pi.
Oh, all right. So at any point not equal to 0, the derivative is 3x squared sine 1 over x plus x cubed cos 1 over x times minus 1 over x squared, right? If x isn't 0, if x equals 0, we have to take the limit as h goes to 0 of x cubed sine, yeah, if x equals 0, then it's x plus h, and it's going to be h cubed sine 1 over h minus what the function is at 0 divided by h, that's h squared sine 1 over h. And the limit of this as h goes to 0 because of the h squared. This is bounded plus or minus 1. This is going to 0 equals 0. So at 0, the derivative is 0. And everywhere else it equals that. And then you can ask, is the derivative continuous at 0? So as x goes to 0, these two, well, remember this is minus then x cubed over x squared. Look at these terms with L'Hopital and decide if it's continuous there. If it's not, how do you move the whole thing to plus 1? Or what is it? Yeah, plus 1. Subtract 1 from x along the way, right? You know, you'd have f of x equals x minus 1 cubed sine. Yeah, that would move the whole circus over to whatever orthology that the original function displayed at 0 would be translated to x equals 1. Maybe we'll run it at 1. So that would be, that's a hint. So dream up, it doesn't have to be that one, dream up something that's, the function's defined on 0, 2, and it's differentiable everywhere on 0, 2. It being understood that the derivatives at 0, 2 are lateral derivatives, derivative from the right. And then, for some reason, f prime is not continuous. The derivative is not continuous at x equals 1. I don't know. This is too complicated. I think I can do better. But if I do better, then I'd have to show you. Then I'd have to kill it. You know, if you start out and say, all right, I want f prime to be 0, and that's 1, it hops. And then that gets that at 2, okay? And then, what about just integrating that? If you do that, the function does that, doesn't it? It's too easy. Sorry, you never saw that one. You can't use that one now. Oh, man, it's going to use that one.
Oh,
She'll multiply everything by 2.
Yeah, it's obviously real.